Hello, you can turn your phone sideways so that you are able to read this. Okay, today we're using the blackboard. So we're going to talk about angles, okay? So start from grade 9, we discuss key concepts, then we build from there. So the first and most important thing about angles is to be able to visualize, okay? One of the biggest weakness that I've seen with most students is they can't tell, they can't even guess if an angle is less than 90 or not. For example, if I say this, then I say find A. So after you calculate, you find your A is 120 degrees, you keep it like that, when clearly this cannot be 120 degrees. So you need to be able to visualize, okay? So what is an angle? An angle is defined as the amount of turn, okay? Let's say you are standing here, right? And let's say you have a long nose like this, okay? This is your nose, okay? So it's like someone is like this person you are looking for. You are in a tree, so this is someone's head and this is the nose, okay? So if this person faces this direction, it means they have turned like this, okay? So this measure of how much they have turned is what is called an angle. So angles are measured in degrees, so it can be like here it's 0 degrees where they're starting from, then maybe here is 10 degrees, here is 20 degrees, here is 30 degrees, maybe here it's 40 degrees, okay? So we can say they have turned 40 degrees, okay? So these are simple concepts that if you grasp them very well, you're going to find angles easy. So common types of angles include the 90 degrees angle, okay, which is denoted by this. So whenever you see this box, just know that this is a 90 degrees angle, okay, meaning the turning is from here to here is 90 degrees, okay? So anything that is, say, like this, which means it's smaller than 90. As you can see, this is big, this is small. Or should I say, the first one, that this one is longer than this. So therefore, this is big than this, okay? But if you have something like this, then, something like this maybe, for you to turn from here facing this direction to face the white direction, you have to turn longer or more than the 90 degrees. So this new angle is bigger than 90. Like you have to move like this. When you reach here it's 90, but you are still going, okay? So that's the kind of a picture I want you to have in your mind. Okay, the other common angle is 180 degrees, which is also called a straight line, okay? So if this is the center and you are facing this direction, so if you turn like this, we say you have turned 180 degrees. 180 degrees, okay? Then what would happen, or what would be the angle if, for example, you are facing where you're currently facing as you're watching this video, then you turn and you end up facing the same direction. Say you are facing here, then you turn till you face back where you are facing. So this is called 360 degrees, okay? You are turning from here, so this is called 360 degrees. So when you turn up to 360, you start counting again. You can't go past 360, okay? So when you're solving angles, you find your angle to be 420 degrees, then question yourself, because angles range from 0 degrees to 360 degrees, okay? Of course, in other contexts, they can go beyond, but in bearing, they can't go beyond 360 degrees, in circle geometry, they cannot go beyond 360 degrees. So if you are solving and you get something 360, laugh at yourself, because you are going to make the examiner laugh as well. So enjoy the moment. Okay, so these are the common types of angles. Next, we look at properties of angles. So the first property is angles on a straight line. So angles on a straight line, let's say this is a straight line, then we say there's this angle here and this angle here. Okay, we call this x, we call this y. Okay, since we know that the total angle on a straight line, it's 180. When you do this, it's 180. So meaning this plus this should give you 180. Therefore we say y plus x should give you 180 degrees. This property is called angles on a straight line. Okay, the next property is in a situation like this. So if two lines are crossing, what it means is this angle, let's call it x, and this angle, let's call it y. These two angles are equal, so x degrees is equal to y degrees. Okay, and also this angle called m, and this angle, let's say b. Okay, so m degrees is equal to b degrees. Okay, so opposite angles in this situation are equal. Okay, so whenever you see this crossing, remember this property. Okay, whenever you see this crossing, remember this property. Okay, the third, which is very important in bearing, is if you have a line like this and a line like this, and these two lines are parallel. Okay, and then there's another line which is misbehaving or cutting them like this. Most of the times it will even just be like this. Okay, like you won't see that it's cutting from one end, like just like this, as long as it's touching the two parallel lines. So these lines must be parallel. You tell that they are parallel if they have these arrows. Okay, these arrows show that they are parallel. Okay, so in this case, the angle here, we call this property colloquially as the z property, because this looks like a z. Okay, so the knees of the z here and here, they are equal. So if this is x, this is y, then x degrees is equal to y degrees. Okay, also this, because we can also say that my handwriting is bad, so I write z like this. Okay, so this is the same as this. Okay, m degrees is equal to n degrees. Okay, so these are the properties of angles that I want you to know. Okay, so now other than this, there is more information. Okay, other than this, there is also another property which is centered on triangles. Okay, if you have a triangle, there are three types of triangles, by the way. There is just a normal triangle, there is a right angled triangle, there is what is called equilateral triangle. Okay, actually I'll just mention three special triangles. Okay, so the first one, this one is called equilateral. An equilateral triangle, equilateral, has got all the sides equal. Okay, that's why we have these three. These three shows that this side is the same as this side, as is the same as this side, which also means that this angle is the same as this angle, which is the same as this angle. So if this is x, this is y, this is z, when you add these three, you're going to I mean the three are going to give you, sorry, the three are equal. Okay, then for this one, which is called a right angled triangle, which you can tell if it has this box here, the only information you can get is it has 90 degrees here, nothing else. Okay, then for equilateral, isosceles has just two sides equal, and therefore these two angles are also equal. Okay, as you can see, the difference between this and this is equilateral, it has 3 of these symbols. Okay, well, the other one has got just 2, it doesn't have this line here. Therefore this one has only these two sides equal, meaning these two angles equal. So here are more properties about angles in a triangle. So angles in a triangle, like if you have this, you have this, you have this, if you add them, you get 180. Okay, so if you do x plus y plus z, they'll give you 180. Okay, so in case you know x, for example, if they say x is 10 degrees and this one is 20 degrees, and they want you to find y, you just have to do from y is equal to 180, you remove the 10, you remove the 20, what remains is the y. Okay, so 180 minus 10 minus 20, it's 150 degrees. Okay, so now if you look at 150 degrees, you ask yourself, can this be 150? No, it can't be 150. This can't be 150 because it's not even bigger than 90. Okay, 90 should be this and like this. Okay, so this cannot be bigger than 90, therefore it cannot be 150. But of course, these numbers, I just chose them randomly to demonstrate the concept, so that's the application. Okay, I just wanted you to always have it in mind that angles should make sense. If you have found an angle and it says it's 150 and it looks like this, just know that you have made a mistake. But here, these numbers, I just picked them randomly, meaning that I did not even think of what the actual or the proper angle could be here and here. Okay, so another property is if you have a triangle like this. Okay, we know that the 3 angles, when you add them, you get 180. Now there's this angle outside which is called an exterior angle. Okay, let's call it x, let's call this one y, this one z, this one w. So this angle is equal to this plus this. So we say this angle is equal to the two opposite angles, two opposite interior angles. The angles inside are called interior, the angle outside is called exterior. So x is always equal to the sum of the two interior angles, y degree plus w degree. Okay, so the last property that I think is also important is, it's not a property but knowledge, is how to name angles. You have this shape, maybe, yeah, we have A here, we have B here, we have C here, we have D here. Okay, so what is this angle? So this angle is, you name it by the lines forming the angle. So the line moves from A, it goes to B, then it goes to C. So this is angle A, B, C. You even put a symbol for angle there, or here at the beginning. Okay, someone can say, what about CBA? CBA is also valid, CBA. Okay, so the angle is CBA. What is important is where it's turning, that's the middle letter, then one of the letters and the other letter there for the arms. The arms are these two. Okay, the one that meets. So naming angles is also a skill. Let me try to create maybe a triangle. X, Y, W, M. So what is this angle? So this angle is angle Y, W, X. Okay, because you move from Y, you go to W, then from W, you go to X. Okay, what about this angle? This angle is angle, you can say W, Y, M. If you want M, Y, W. Okay, so it's MYW. Okay, what about this? It's WMY or XMY or YMW or YMX. Okay, so that's how to name angles. Though sometimes it can get tricky, but I won't push you in that direction, because you might see something that I don't want you to see, which can become a lifetime confusion. Okay, so it's better that you don't know. Sometimes it's good not to know. Yeah, so so these are the key properties that you need to know before learning bearing and circle geometry. Now on bearing, there's also one more information that is key. Bearing, we use a compass, okay, like this. Okay, so each of these is called an arm of a compass. So there are 4 arms here. Okay, so one arm, the angle between one arm and the corresponding arm is 90 degrees. Okay, so the arms are at 90 degrees. Okay, oh, my phone is about to turn off. Anyway, 90 degrees, 90 degrees, 90 degrees. Okay, so again, when they say that, for example, B is due east of A. So if this is our A, B is somewhere here, they mean B is on the east of A, meaning that if you're standing on A, B should be on your east, meaning the angle between the north of A and where B is 90 degrees. How much time have I used? Okay, so basically that's it. Maybe I can even take this opportunity to do an introduction to bearing. Of course, there's already a video for bearing, but just an introduction. So bearing simply is you measure the amount of turn from north to some other place. Okay, so let's say we have this situation where we have sometimes they like bringing a triangle. So why do they bring a triangle? So that you can use properties of a triangle that we learned. Okay, so I've got these places. This is A, this is B, this is C. So they say maybe they say here it's 40 degrees. Okay, this can't be 40, so this is maybe 60 degrees. Then here they say here is 20 degrees. Then they say find the bearing of C from A, of C from A. Okay, meaning that when you're standing on A, how do you face C? So the first step is to draw a compass on where you're standing, A, right? So you draw a compass like this. So your job is to find this. Okay, your job, by the way, this is north. Okay, I mean, I can't write properly, but this arm here is north. So if they say find the bearing of C from A, it means when you stand on A, you are facing north. How can you turn to face the line that goes to C? How can you turn to face the line that goes to C? So that's what we're looking for there. Okay, so there are different techniques you can use here, but the job is just to find how can you turn to face C. Okay, so let's try to think. So bearing, circle geometry, it's not like the other types of mathematics where you start solving. No, you have to spend maybe 5 minutes, 3 minutes thinking. Okay, you think. Once you have a plan, that's when you execute. So we're going to think together, because this question I've just created it randomly. Okay, so we're going to think together. How can we find that angle? Okay, so this part we know it's 90, right? because the arms are at 90. But this part we don't know. Okay, also we know that this part is 180 because this is a straight line. This is a straight line, 180. Okay, but we don't want this part, right? So if from 180 we can remove this part, what's going to remain is this part. Okay, so this is the thinking before start solving. Okay, so how is it possible for me to find this? They have given me schist. Some of you may be tempted to think that this is 30. No, you can't just think this is 30. Okay, because how are you sure that this divides this and this equally? Okay, there is no information, you can't know. So this, we cannot just assume that it is 30. So how can we find this? So now we start thinking about this. Okay, this one is schist. So if from this schist, since I want to know this part, so if from this schist, if I can remove this part, I'll remain with the part that I want. If you remove this part, you will remain with this part that you want, right? Is it possible for me to know what this is? Okay, you ask yourself. So now most of the times in bearing, the Z formula, or the Z property helps. So is there a Z between this angle? Try to continue the line. Okay, this angle, there is a Z. This is a Z. It's like this, meaning our angle is here, so it is equal to this angle. Okay, therefore here it's 20 degrees, just like here. Okay, so now from this 20 degrees we remove 60. Okay, I mean from 60 we remove the 20, we remain with this angle here, which is 40 degrees, right? From this full 60 we remove the 20, this small part, we remain with the 40, right? Now this whole thing up to here, it's 180. This whole thing up to here, it's 180. But this small part we found it's 40. So 180 minus 40, we get this as the remaining part. So 180 minus 40, it's 140. Okay, so this 140 degrees is the bearing of C from A. Okay, so the bearing of C from A, we write 140 degrees. Just wanted to show you the application of the concepts, how to use them. Here we've used angle on a straight line, 90 degrees. We've used the Z property. Okay, that's how to tackle bearing. Okay, so check out the other video for more explanation.